Awesome. So welcome, everyone. We are the Thames Region Ecological Association. I'm Caleigh, joined here with Diane and Ava, and we're here to present the Soil-ution to a Sustainable Future. So thank you for coming, and we all really appreciate your interest in wanting to create a sustainable future for us all to be part of. So we're going to start off firstly with a few polls just to gauge your understanding, see kind of what you know already, and then see where there's areas to learn. So we'll get it started there. Perfect. Okay, so not too many people have heard of the food web before, but we will change that today. So let's see. And then we have one more poll right now. Okay, and then here's our next poll. So can soil solve climate change? A broad question. Let's see.
That's a tricky question.
It is. Possibly, but not alone. Okay. Yeah, I would say pretty true. It has a lot of potential, which we'll see today, but let's get into it. As you can see from that video, soil plays an incredibly important role, and our agricultural systems are very, very stressed right now trying to feed the global population sustainably. So today we're going to show you two more short videos explaining a bit more about soil and our current struggle that we're facing to try and feed the world sustainably. And then we're going to head into a quick activity that I'll run showing you how you can make a composter at home to make your own healthy soil for your garden. And then we'll explain how you can get a bit more involved and learn more about this issue. So without further ado, we'll head into the next video.
What is the soil food web? To understand the soil food web, let's start with the term food web. We all know about the food chain, the animal kingdom on top of which are us humans, right? Well, if we look a little closer, we can see that some members of the food chain don't just eat one thing. That goes for humans too. So the reality is more like a web than a chain. This is the food web. There happens to be a food web in the soil too. This is the living part of the soil made up of insects, earthworms, and much smaller microscopic creatures such as fungi and bacteria. Dr. Elaine Ingham has pioneered research into the microorganisms in the soil over the last 4 decades, and has worked with a team of research scientists to understand how they interact with each other and with plants. The soil food web can be thought of as the soil biome. Just as humans have a gut biome responsible for digesting our foods, so too the soil has a biome, which breaks down organic matter and releases nutrients in plant-available form. This is how nature has been feeding plants for billions of years. The major groups that make up the soil food web are bacteria, fungi, protozoa, and nematodes. When in balance, these different groups interact with each other and with plants to create abundant ecosystems such as the great forests of the world. Have you ever wondered how forests can be the most productive ecosystems in the world without the need for any fertilizers or pesticides? The answer lies in soil biology. With a healthy biome, the soil can provide plants with all the nutrients they need, and with a number of other benefits, such as protection from pests and diseases, protection from drought and from flooding. The soil food web is, essentially, nature's operating system. Unfortunately, we humans have disturbed the soil food web in almost all of the soils that we manage, causing it to become unbalanced. As a result, the plants we grow struggle. Plowing is the major cause of the problem, as it destroys the larger microorganisms, such as fungi and protozoa, leaving the soil food web out of balance. This results in a system breakdown. Nutrients are no longer made available to plants, and protection from diseases is compromised. Before the Industrial Revolution, humans would plow using oxen or a bull, which provided around 3 or 4 horsepower. Modern tractors can yield 400 horsepower or more. So far more damage is done to the soil biome by modern machinery. The use of chemicals has compounded the problem. The good news is that we can restore the soil food web to most soils within just a few months. This results in a number of benefits, both for farmers and for the environment. With a balanced soil food web in place, farmers need not use fertilizers at all. They don't need to use pesticides either, as nature's operating system protects plants from attack. Herbicides, used to kill weeds, are not required either, as weeds only thrive in conditions where the food web is out of balance. Restoring the soil food web means farmers save money on chemical inputs across the board. It also means that their yields increase dramatically. In some cases, farmers working with Dr. Elaine Ingham have seen yields increase by over 200%. This is because the soil food web provides plants access to a constant flow of nutrients from soil organic matter, and from the soil particles themselves. That's right, sand particles contain nutrients, and guess what? Fungi and bacteria can harvest those nutrients. They then make these available to the plant in a process that the plant actually controls. This means that plants get access to the type of nutrients they need precisely when they need them. That's how you maximize yields and optimize profits. For the environment, there is a whole host of benefits of having a balanced soil food web. Humanity is facing a number of existential threats. Let's take a look at how some of these are related to the soil. The most obvious one is soil erosion. The United Nations Food and Agriculture Organization has estimated that we only have around 60 years left before all the world's topsoil is depleted. Other estimates are as low as 30 years. The soil food web prevents soil erosion by both wind and water by building structure. Please watch the animation on soil structure for more information. Another existential threat we are facing is ecosystem collapse. The UN has recently stated that insect populations have been decimated by around 25% each decade for the last 30 years. That means that there are 57% less insects today than there were in 1989. Bird populations have declined by 1/3 in the last 15 years in parts of Europe. So how does the soil food web help? Well, the UN has identified the use of pesticides as a major cause in the decline of insect populations. Please watch the animation on pests and diseases to find out how nature's operating system protects plants against attack, eliminating the need for pesticides. Another threat to life on Earth is climate change. Fortunately, the soil is capable of holding tremendous amounts of carbon in the bodies of microorganisms, and some mega-organisms too. The biggest living organism in the world is not a whale, it's a fungus found in Oregon that is the size of 1,665 football fields. It is between 2,000 and 8,000 years old, and it is made mostly of carbon. By restoring the soil food web, we could put a stop to climate change. Please watch the animation on soil carbon sequestration for more details. At the Soil Food Web School, we train people like you to help farmers transition away from using chemicals to farming in harmony with nature by restoring the soil food web. For more information about the numerous benefits of the soil food web and how you can get involved, visit soilfoodweb.com. How is carbon stored in the soil? During photosynthesis, plants absorb CO2 and sunlight. They release oxygen and produce sugars, carbohydrates, and other long-chain molecules that are mostly made up of carbon atoms. Plants release up to 40% of these carbon-rich compounds into the soil as exudates to feed fungi and bacteria. They do so in order to promote growth in the populations of these beneficial organisms, as this will eventually result in a return of nutrients to the plant. Please watch the animation on nutrient cycling for further information. Fungi produce mushrooms on occasion, but that's just a small part of the way they grow. The majority of the fungus consists of hyphae, long, narrow tube-like structures that are made mostly of carbon. As a fungal hypha grows, it gets longer and branches off in different directions, looking for new food sources. Over time, its walls grow thicker and thicker, storing more and more carbon as the fungus continues to absorb exudates from the plant, and also organic matter in the soil. So how can this help in the battle against climate change? Well, the biggest single organism ever discovered on planet Earth was a fungus in Oregon that measured approximately the size of 1,665 football fields, and is somewhere between 2,000 and 8,000 years old. That's a lot of carbon being stored up for long periods of time. So you can think of this as a kind of carbon pump. Atmospheric carbon is absorbed by plants and pumped into the soil, where it is stored for hundreds of years by fungal hyphae. This process is known as soil carbon sequestration. How effective could soil carbon sequestration be in the struggle against climate change? Well, estimates vary, but here are some reasonably conservative numbers. Atmospheric carbon levels are currently just over 410 parts per million. That's totally off the charts when you look back over the last 450,000 years, as climate scientists have been able to do using ice core samples. This number has not been above 300 parts per million in that time. The red line on the graph is temperature change. As you can see, there has been a clear correlation between temperature change and atmospheric CO2 over the last 450,000 years. If the temperature continues to rise in accordance with current CO2 levels, then we're going to see some dramatic changes to our habitat. Just to put that in perspective, humans have only been on the planet for around 200,000 years, so we have never seen conditions like those currently being modeled by climate scientists. What is considered a safe level of atmospheric carbon? According to the United Nations IPCC, this is somewhere around 350 parts per million. That's around 60 ppm that need to be removed from the atmosphere, which equates to approximately 450 billion tons of CO2 equivalents. We're gonna need this number in just a minute, so let's put it over in the corner here. How much of this can be sequestered into the soil? The answer is, we don't know. What we do know, however, is that it is possible to sequester in excess of 10 tons per hectare per year, and possibly as much as 20 tons per hectare per year, as demonstrated by Dr. David Johnson at New Mexico State University, who has been successfully restoring the soil food web. Yes, this is cutting-edge research, but with more investment, this could possibly become achievable worldwide quite quickly. Humans manage approximately 5 billion hectares worldwide, so based on 20 tons per hectare per year, that equates to 100 billion tons per year. Total greenhouse gas emissions for the entire planet in 2019 were around 37 billion tons. About 50% of emissions get absorbed by natural processes, according to research by NOAA, leaving around 20 billion tons in the atmosphere. So if we did nothing else but regenerated the world's soils, we could potentially sequester about 80 billion tons per year. 450 billion tons divided by 80 billion tons per year means that we could theoretically get back to 350 parts per million, the safe level, within 6 years, just by regenerating the world's soils. Of course, we cannot do that overnight. Allowing time for global implementation, 10 to 15 years is a more realistic time frame. If you factor in reductions in greenhouse gas emissions, the picture begins to look far more optimistic. The bottom line is that this could be a big piece of the puzzle when it comes to fighting climate change. For more information about the numerous benefits of the soil food web and how you can get involved, visit soilfoodweb.com.
So as you can see, there is tremendous potential for soil to help solve climate change. So next we'll be going into our own backyards and seeing how we can make our own healthy soil at home through making our own compost systems. So I'll share my screen with some ingredients that you guys can gather at home, perhaps after this. They're everything you should have already at your house. They're all kind of waste items, of course, as compost is. Or I'll just put the list up at the end, so then you can take a picture of it then, but I'll hold up the objects right now. Perfect. So we're going to start with a plastic container. You'll also need some dirt, plant scraps, paper, a push pin, water, and a kitchen cloth. So you're going to want to start firstly by grabbing your old plastic container, preferably something clean, maybe a bit bigger if possible. This is all I had and didn't want to create more plastic waste, so this is what we'll be using today. So you're going to grab your push pin and start by just poking some holes in the bottom like so. So this is for the water to be able to drain out as you water it each day. Perfect. So once you've done that, it'll have some holes in the bottom there. And then you're going to want to grab your dirt here. So let me move my screen a bit so you can see what we have here. You're just going to grab any dirt you can find on the ground. Again, very accessible. Some of that. And then add some leaves. Any natural debris works. It all comes from the ground and will go back into the ground. Throw in some paper scraps there. You can shred it up a bit if you'd like. All of this will be available afterwards too, so don't feel like you need to take notes or anything. And you're going to want to add a little bit of water to it, just a small amount. You can use a spray bottle if you prefer, but just drizzle that in a bit. And then you can stir it around a bit. I'm just using an old toothbrush, but again, anything works. Maybe a stick if you're already going outside to gather this stuff. Perfect. So that's your base layer there. So again, that's just paper, a bit of dirt, water, and some leaves. Any organic material works. And then this is when you are going to add your compost material. So any fruit and vegetable scraps, eggshells, that kind of thing. Anything that you would typically put in your compost system. We don't have one in London, as you guys know, but hopefully we will be getting one soon. So just grab all your old scraps. I'm going to crumple mine up a bit, but you don't have to. Perfect. Awesome. So there, that's what that looks like now. That's proud Canadian. There you go. And then add a bit more water again. And so every single day, you're going to want to add a bit more water and just keep stirring it around. So now it's really getting in there. And then just put it on a plate or something like that so that the water doesn't leak anywhere. And then you are going to want to put this in an area with a lot of sunlight and just put a kitchen cloth, any cloth will do, over top like that. And then each day you can add more food waste scraps, any vegetables, again, as I mentioned before, fruit, paper if you have it, old paper, and just stir it around and keep it in the sun. And then you're going to have to wait a few days, be quite patient, but keep watching it and see. You can slowly see as it turns into healthy soil, and then you can put it into your garden and watch your plants grow. So I will share my screen now, so you can take a screenshot or a picture of the ingredients list and the steps that you have to take, and then we'll keep it going. Perfect. So how can you get involved? So as I mentioned before, we are the Thames Region Ecological Association, and we are a charity based out of London that is focused on getting people to take personal actions to help solve climate change and create a better environment that we all want to be a part of. So we're always looking for more volunteers and members. So please check us out on Facebook and check out our website to see how you can get a bit more involved. And we also recommend checking out more on regenerative agriculture. So regenerative agriculture was discussed primarily in the videos, but that's all about regenerating the soil and making sure that it's healthy and able to sustain our populations for years to come. So we know that most people have Netflix, so I would recommend Kiss the Ground and The Biggest Little Farm. Kiss the Ground has Haymitch from the Hunger Games, if anyone's familiar with him, so would definitely recommend that one. And The Biggest Little Farm is an awesome farm that is in California, and they completely redid it to be regenerative instead of traditional industrial agriculture. So I'd really recommend those. And thank you for coming out, and we hope to see you at the next TREA meeting. Thank you.